Okay, integration. So by firstly recalling the process of differentiation, write down the process of integration, giving some examples along with a generalization. Now, okay, let's look at some examples then to start with of differentiation. All right, so if you recall, suppose I've got a curve such as this here, okay, y equals x cubed plus x squared plus 7, and I want to differentiate it. So remember, when you differentiate it, you do dy by dx, okay? That's what you get when you differentiate. That's what we write there, yeah? And you remember then, when you differentiate, you bring the power down, don't you, in front, and times. So it'll be 3 times x there, okay, 3x, and then you take away 1 from that power. So you get squared there. We remember that, don't we? Same here, you bring that power down in front, 2, and then you reduce that power by 1. So the power 2 there just becomes 1, doesn't it? When you take away 1 from it. I'm not going to write 1. We've got that there. And remember then, 7 is a constant. When you differentiate that, you just get 0, don't you? So that's when you differentiate. So what is integration? Well, quite simply, integration is the opposite, okay? We'll actually reverse the process, okay, if you want to in this case. So reversing the process should get you back to where we started with, yeah? So suppose I want to, suppose I've got this here and I want to get back to where I started from. I'd need to integrate, okay? I'd need to do the opposite of what I've just done. I need to do the opposite of differentiation. And to do that, we use this symbol, okay? So when we differentiate, we write down dy by dx, okay? But when we want to integrate, we use this symbol here, okay? It's a bit like a sort of elongated S there, right? So you've got 3x squared plus 2x. And always, right, every time you have to write at the end dx, okay? Because what we're saying is we want to integrate with respect to x, okay? So because in terms of letter x, we want to do it with respect to x. So that's what that means there, okay? So, equals. Now, how do we go about it? Well, quite simply, to integrate, it's the opposite process, yeah? So you do the opposite of what we've just done here. And when you do the opposite of what you've just done here, you have to do the opposite, but also in the opposite order as well, okay? So when you take this here, 3x squared, well, the opposite now would mean that we need to add 1 to that power, okay? So 3x squared, right, here, well, if I add 1 to that power, 2 will become 3. And then I need to divide, okay, by that power 3 there as well, okay? Because if you think about when I differentiated, I brought that 3 down and I multiplied, didn't I? Okay, well, now I need to do the opposite, and the opposite is dividing, okay? Let's look at the second term. Exactly the same process here. So the first thing you do is you add 1 to the power, okay? So the power there is just 1. So if I add 1 to it, I'll get 2, and you divide by that new power. It really is that simple, okay? Now we have a little bit of a problem though, okay? Because I've done those 2 terms there, but in the original, I had 3 terms, didn't I? And there's not enough information here to tell me what number I need to add on at the end here, okay? Because of course, when you differentiated, it became 0, yeah? So if you've got 0 here, we don't know that that would be 7 when you integrate it. So what you've got to do always is you've got to put a plus C on the end, right? And if you think about that letter C, think about what that would stand for, C. In maths, we use C to represent constant, yeah? So basically, there's a constant that needs adding on, okay? Right? In this case, it would be 7, but in other questions we get, we might not know what that constant is. Okay, we might not be given this, and we might just be asked to integrate this. So we just say, look, there's a constant there at the end. And what you'll find as well, then we can simplify this, and we get this then. So 3 divided by 3 is 1, so you get x cubed, 1x cubed. 2 divided by 2 is 1, so you get 1x squared. And then you've got that c on the end, okay, which we know in this case is 7. Okay, let's look at a second example. Suppose I'm asked to integrate 4x cubed plus 9x squared dx. Suppose I'm asked to integrate this. So remember now it's the opposite of differentiation, okay? And we do things in the opposite order. So you can see here the integral symbol with respect to x. So quite simply you take the first term there and then you add a power to it, okay? So because the power there is 3, if I add 1 to it, I get 4, okay? But remember then you've got to divide by that power, which is 4 as well. And then the same thing then, 9x squared, well, you add 1 to the power, so squared will become cubed, and divide by that power, okay? And don't forget then, always you've got to put a plus c, okay? So what happens then is 4 divided by 4 cancels, so you get x to the power 4, okay? Or 1x to the power 4. 9 divided by 3, 9 divided by 3 is 3, so that becomes 3x cubed. And then you get a constant at the end, okay? And there's the answer there, okay? We've integrated. Now what you can do is you can check then to see, by differentiating it, to see if you get back to that. So if I differentiate that, well, differentiate this, remember you bring the power down, so before x, and then take away 1 from that, so you get cubed. There you go, we've got that. 3x cubed, bring that power down, so you get 3 times, if you bring that power down, you get 3 times 3, which is 9, x, and then take away 1 from that, you get squared. And of course a constant could be any number, but when you differentiate just a number or constant, it becomes 0, yeah? So we get exactly what is there. Okay, so in general, when we integrate, suppose I've got to integrate, say for instance, x to the power n, where n could be any sort of number or any value, okay? What you've got to do is, remember, you've got to add 1 to the power, okay? So this is the generalization of it. You add 1 to whatever n is, and then you've got to divide by whatever that power is. Okay, so whatever that power is, you divide by it there, but not forgetting to put a plus c at the end.